Okay, so I have a midterm and a final soon. Since I have a final, I decided to do all the homework again. Sounds like a psychopathic move, but it's actually helpful. So right now, I did homework one to homework three again, and since I'm doing my homework again, it's really good if I understand it. And to understand it, explaining it to a random stranger to myself, or just make a video to make it understandable. Because if you don't know how to say it, explain in a way that makes sense, then you don't really understand it. And my mentality. So this was the first hallmark. It was talking about uncertainty. Uncertainty is different from standard deviation, which we'll talk about more of because that point is important. Which I just realized while doing all the homework again. There's things that you realize if you do all your homework again that you never realized the first time you did it, and that's one of the things I never realized until recently. So we are first going to talk about a deck of cards. This is a simple question that we were given in the start of the year, which I'll be honest, part B, I did not understand at first. I was confused as hell. But let's go with this one. We know that this is the original uncertainty, which is the error ratio, with the 0.59 inches over here, which is 0.005 inches of error. And then we're asked for one card of uncertainty, which is divide by 52 is so simple to get 0.01. Now, what I'm incredibly surprised about part B is that it works. I don't know quite why it works until recently, but I mean, kind of. So, I got this part. I wrote this part wrong. So, that's 5. Why is that 5? So basically, I tried 0.05 0.005 divided by 250, which is the cards they said, and I got exactly 0.00005, I believe. So like it got 2e-5 in my calculator. Also, we do need this table over here, this table A, which is the for homework 1 to 3. I think other homeworks need the other BCD table, which we'll talk about later when the appropriate time comes up. So yes, so we get 0.0001 inches. So that's the uncertainty for one card. If we have 52 cards, the reason for that is think of a measurement device. Okay, if we have a measurement device, and there's a certain amount of error in that measuring device. If I measure this about here, is we are given the error of 0.005. That would not matter if I measure this whole thing. It'll still be 0.05. So if I divide this by this, I miraculously get, where was it, an error of this. Uncertainty of that, the amount of uncertainty and leeway we have. Which, if that is so true, this method works. And what it is saying is that there is already a t. T is the thickness of one. Oh no, thickness we want, and this is the thickness we get. Like I'm sorry, I'm confusing my name. This is the thick. This is the thickness of one, and this is the thickness of many. Which, if you divide these two, you suddenly get 250 cars. What I know about this is it works. Therefore, the textbook say it gives you a memorization thing. In I forgot what page it is. It's page 3. So let me just look up the page. Um, I think it has to do with percentages. To be honest with you, which is interesting. Yeah, I'm trying to look for the page number. But if you plug in the calculator to this thing to 230 cars, which is 0.005 divided by 250, you know what? Maybe it's better just me to write it because obviously I'm saying this a lot. 250, this equals 0.000 CO2. You could try test it out. It actually works, and I was quite shocked by it. Which means this method actually works. It's just that I don't understand the method quite well enough in a common sense way. But this method works, and in the textbook, it just gives you the formula and it says to do it if you're given this question, which I'm fine with. I just don't quite understand why, but we'll move on to that. Anyway, the next part is we need the partial derivative of this because the formula, first time you're doing it, you're kind of confused about doing this because you don't really understand what you're doing because until you do a lab report and do it like 20 times, because you have to do partial derivative 20 times to get an error, uncertainty later on, it makes no sense what's happening here. So, um, we know the formula of the period, this period, the pendulum's period. So we get partial derivative to L. L, we get partial. We treat everything else as a constant. So this is moved out, moved out. We put it like this. So imagine there's a guy here. So this portion is a constant, which is over here. These three. So we get this, and then if you take a partial derivative, take a derivative of square root of L, you would know it's actually divided by two. So it's actually well, square root of L equals 1 divided by 2 square root of L. So I divide by 2, which gives you 1.00303, which divided by square root of L gives you this number. But why do I multiply by 0.01? That's because of the formula again, which is 0.0. Wait a second. Yeah, that's true. But aren't I supposed to square this too? Yeah, I'm supposed to square this and square root it. Oh, right, because it's one variable. If I were to square this and square root it, because that's the normal formula, they would just cancel each other out because it's only one variable. If there are multiple variable of error we added together, then we need that square root. Yeah, I forgot about that. So let me get a. So for normal finding an error of something, we would need the square root. If let's just say the equation equals 1 divided by 2 mr, and these two have errors in them, or uncertainties, whatever you call them. And the uncertainties for this was 0.05, and this was 0.05. Let's just say that. So the uncertainty m, which is uncertainty m, is this goes in here with the partial derivative of a certain partial derivative. What again? It was partial derivative of no, it's the m on top. No, I keep on forgetting which one's on top. Oh yeah, that one's on top. So this is on top divided by uncertainty m over here square plus this uncertainty. What's it again? R by error over here. Actually, probably should I just write D. Now think about it, my lab report. I didn't use D. I used I used this as my error, which is completely fine, I guess, as long as you know what you're talking about. D E. Sorry, I'm messing that up. And then R over here, right? And then we have square over here. And that's how you get the error in the most simple sense. Although there's some tricks and tricks. So if you're given these kind of questions, you can turn all of this into that format to figure out error because you can think of this as x, y, and z. And you can think of it as an equation, and therefore you're just doing what the equation does, which is getting a partial derivative of something and doing the whole shenanigan again. You can think of it like that. Anyways, so we get this, right? Multiplied by 0.0 because this, and doesn't matter because just one variable square and then square rooted. So I can get that as an error over here. We move it right over here to 2.2374 plus or minus 0.008, which is error of a t. The t is a particular value of the this equation when the L is this big and we see the error is that big. We hope that's the error, but in reality, there's more errors called the human error, which we, which we hope to not get, but yeah, um, because which we lower it by dividing some. Imagine doing a period and we do period going back and back. There's a human error of trying to stop the pendulum, no, look at the pendulum, tell us when the pendulum stop in right time, like 20 periods stopwatch. So you'd want to do multiple periods, like 20 periods, and divide by 20 to get the error reduced. The human reaction error is about 0.3 seconds. But the environment and the pendulum and the top of the pole, the friction will give you more error also. So counting that in, it's probably more like 0.5 for that. But yeah, whatever. I think I put like 3 seconds on that there, but because it was such a be pain but it's divided by something and it just gets away. Anyways, next part is we are given the measured error, measured 2.38 plus minus 0.01 is consistent with the theory or not. Well, this is much bigger error as we can see from here. This was 0.0008 and this is just basically over here. Now, what we do is see if it overlaps. We have 2.40 and 2.38 if this is 0.7, right? So first thing I notice is 2.374 is between these. Am I doing something? No, 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 I'm doing this wrong. So yeah, we see that is in between. Oh, they do not overlap. Did I do this question wrong? Oh no, they do overlap slightly. 3.82 over here. And then that they do kind of overlap. So I think I said that is sort of consistent, is not really close, although I can't actually say this. But it is inside of, it is overlapped actually. So they do overlap, therefore a little bit at least. So we can say that it's kind of so consistent, if I'm not correct. I don't remember if that's correct. Did I get this question wrong on Grayscope? I don't think I can show you my Grayscope because it shows more private thing. What I don't remember actually. Whatever. I think that's good enough. And then this part. So there's a few tricks we need to know about this. So the internet, I kept on finding internet videos, and they show that you can just add these two, which is completely wrong. That gives you four, right? No, you can't do that. I don't know why they think you can, but you're supposed to do this. So if you minus something or add something, you need to follow this procedure. So 25 minus 10, which is 15, very simple. The square root of the uncertainty is 3 and 1, which gives you, let me see, second square root of 10 gives you 3.216. So already we're a different start where it's 15 plus or minus 3, which is completely different than what the thing I found on the internet was, which is kind of weird. Did I not finish A? Because I'm supposed to multiply this by 12 plus or minus 1, but I don't see that. Oh, shit, I did not. Yeah, I don't think I did. Oh shit, I did not do that. Well, that's not hard to do, right? And I can explain it very easily, but that's a shame. Because the trick is that, let me change this to 3. If we change something to 3, it means that we already decided the significance of it. Again, no notification about something that I don't need. I need probably some. Let me check something real quick. Oh, they're asking. Oh, someone's asking about the L1 string. 50 point. Uh, L1 is a yeah. So sorry, I just got a message from someone that they're asking for help on the question. So, who's this? L1 is question length, and the city is the area of the moving capacitor. If I'm not correct. A descendant something. Anyway, we can go back to this. Part B is doing the same. I didn't finish the question that I was doing. So I, for some reason, did not do this question. So we did one. We had to do 1 divided by 12 over here, which equals a percentage. The square root that. I mean, we could do if you want to treat this like x and y, the partial derivative all the way. Uh, Let me get sorry, man. The pendulum. So, and then plus, I believe that would be 3 divided by 15 squared. Let me get that real quick. Someone's a bit lost. All right, let me see something. Who is this guy? Oh, it's Gary. Okay. All right, I'm a bit lost. Sorry, I'm just. Yes, follow the rubric. I might want to check. One thing that I think flows completely. Well, and then let's just see what I get. So I need square root parentheses alpha. This 1 divided by 12 parentheses square plus parentheses alpha. This 3 divided by 15 parentheses squared, which equals 0.126 something percent. And then we just do what do we get? 12 multiplied by 15, which is what? 80? Sure, dude. I had to double check this afterwards. 180 multiplied by 0.26. And then that is 46, so it's like 50 about. That seems kind of big. And yeah. Well, let me check the time of this. The diameter, the moving capacitor. Oh, let's bring this guy. That's literally what the diameter is. I don't know. Anyway, so we can move on. If I'm wrong, if I got the wrong answer by accident, I can retrace it and figure that out later, uh, and then make another video on it. But I know the rest of the questions are correct, hopefully. So we have this, which we get the percentage of, and we square root it by 4, and then we do a division to get 1/4, and then we multiply it by 2, divide it, multiply it by half to get 1/8, which is a percentage again. It's all percentage because when we're multiplying, when we have a power or square or something like this, you can do it two ways. You can do the fancy partial derivatives and shenanigans like that, which takes a while, or you can simply just do it. By that, you can just simply just, what's the right word? um, not do partial derivative and just do it by the percentage and everything, because we already know the truth, because someone already did the partial derivative a long time ago and found the pattern already, and you don't have to do the pattern yourself, and it takes a lot of time off of you. So we get a percentage here. This is 3. I keep on making a mistake earlier where I thought that was 30 and got the ridiculously stupid answer. And then multiply 100, which gives you 2.7, 2.7, not a percentage here. So here's the thing. You round it up to 3. One digit, unless it's 1, which we'll talk about later. If it's 1, like it's 1.5, you can keep it to 2 digits. But yes, 2.7 plus or minus, you get this. We want it to be 2 point plus or minus 3. Um, where did I where did I go with this? Put it here. As you can see, I did the same thing over here. I think I decided to go over here and do it this way because that was way faster, which is 3.6 over here. I did that, which is for 54. What was 54 again? Ah, yeah, 54 is over here. So I multiply these two to get 54, and then 6.6, which gives me over here to 7. Again, I simplified it to one day. This was actually a lot longer, but I only needed it to one digit, so I just checked the last one and did this. And then I added to here, which here it is, which is 7.201, which gives you 58 plus the 7 for B. So yes, percentage is powerful when you're multiplying and having a power, because it just gives you an easy way to do it without doing all the partial derivatives and blah blah blah. It also gives the opportunity, but you have to always change it back to regular numbers. So imagine every time you do a percentage calculation like this, you have to change it back to a number, and then you have to round it up or round it down depending on if this is a larger than 5 or smaller than 5. If it's 5, then you round it up like normal. So C is the hardest one because you for this question, because you need to use partial derivatives. A simple one, because it's I chose we could have, if we really want to be a sadistic person, we could have done y equal z e x negative. We could have done this if we really wanted to do it. This is an option, a psychopathic option, but an option nonetheless, where we have a f formula x comma this, and we can do z e negative x and do a partial derivative on y and x and get and then you had to get the errors and then attach it back to this answer and then get the answer right there, which so basically, first you have to do the main portion and then you have to do the error portion, always. So doing that is a pain in the ass here because we're taking a partial. You first of all you need math 20C content, which why the fuck would I do that? Um, because it's just pain in the ass. Due to the So like, so yeah, because partial derivative is a double function, which whatever you can super easy. But why would I want to do that? Instead, I take a partial derivative of e to x and consider this a constant. I multiply this later. I say, yeah, there's an error portion over here, but I'm just gonna ignore it and focus on the e to the x first. Uh, Mainly because this is a question I could do it. If this was what's it here, a research paper, I would just do this method over here. Why? Because it's simpler, it's faster actually, just to not think of it. It's like a drone work. If you're doing like a lot of partial derivatives and you don't want to think about it, just partial derivative everything. It doesn't matter. I mean, you're going to get the answer anyway. So I do that all the time. I don't even think about it until the last research paper that no experiment paper. Sorry, I'm talking about experiment. Sorry, this is lab work. Keep on doing it wrong. I meant experiment lab paper. If you're doing a lab paper, uh, I just doing it like that because it looks complicated. It just gives you the same answer, but I don't want to think more than I have to for a lab paper that I don't give a crap about because it is It's a large portion of a grade, but it's a lab paper nonetheless. It's boring to write. I don't know what I'm talking about anymore. Fuck me. Anyways, e to x over here, negative x. So we get a partial derivative over here, and then we plug everything back in, and then we get negative 1 to 0.04. Anyways, yeah, I did that, and then got this. Why do I keep on saying research for I meant lab paper? Sorry, I mean lab paper. My brain's losing it from all this doing all the homework from homework 1 to 3. But I'm gonna do 4, 5, 6 later, and then I'll do homework on physics because I physics 2C has a bunch of topics I'm revisiting in the textbook that I am writing down and then gonna re-explain to enlighten my head a little bit before my next quiz and then the final. And then getting ready for. Anyway, so yeah, you get 0.07 by doing this shenanigans, which actually you don't need this because I said this is one variable problem, so you don't actually need this. So you can delete that and got the same answer over here. 0.07 over here, and then this over here from plugging this in. Oh, by the way, if you did use a partial derivative method in this over here, what would happen is you don't need to change the percentage to thing and make it easier for yourself, which is another reason why I like the drone method because I don't have to think of percentage ever again. Which I know some people hate percentages. If you hate percentages, just do the partial derivative method because it's a drone method and works very well for a lab. If you have a class that has a lab, I keep on making a mistake in my head on saying lab and research. It's different. Lab. I meant lab. Anyways, 7.4 plus or minus this over here, and that's percentage over here because what am I doing here again? Oh yeah, 2 divided by 20, and then 0.04 divided by 0.37 square rooted here, and then you get this percentage over here because again if you do this method you get a percent. You do not, I repeat, do not get a answer. If you have written it like this, if you it would be totally wrong, and I'll do it like this because I don't want you to think this is right. 1 point of 15. Yeah, that's completely wrong. This is just completely illogical. Um, yeah, that's completely illogical. So what you need to do is turn it back to the real numbers, the unit that you asked for. So y units, the y units is something that presented, and you can choose two ways to answer because it's a one, and one is special. Because unlike if I got 2.02, I need to get to one digit error, plus or minus. But if I have a 1, I can actually have a 1.02 or 1.0 or just 1. Or that's a bad example. Say it's 1.1. I can get it to two digits or I just can leave it as one digit and be done with it. Which means if I get 1.6, I can leave it at 1.6 or change it to 2. It will not matter. And that's such a weird thing that I learned in this class. Oh yeah, this problem, which some of these questions are optional. You don't have to do them for this class, which is this is an optional question actually. I just did them because I thought they would help me, but apparently they don't really help you. So um, this problem is goddamn awful. I'll say that. So you have this, you have this, you have this. You have to make the whole chart. I did this for my when I submitted this into Gradescope. So Yes, this whole chart. This actually was optional, so I didn't have to do it. I didn't even get graded on this on the original one I did in grade scope. So fuck that. Um, anyways, this over here is a chart that you can do in this